Is about solving rational equations. Equations where you have x's in the denominator on one side or another, or both. The first thing to understand about solving rational equations is the power of that equal sign. This thing is a big deal. When we had an expression, something that didn't have an equal sign, you don't need to put this in your notes, but 1 over x plus 2, I don't know, let's keep it simple, plus 3. We learned that the only way you can add those two things together is if they both have the same denominator. And the only way you can make a change in an expression is if you multiply by 1. You had to multiply by 1, which is why we choose to write times x plus 2 over x plus 2. We're allowed to do that because you're multiplying by 1, and that is literally the only thing you're allowed to multiply by in an expression. And so we would put those two numerators together over the denominator, and we can go from there. Great. When we have equations, though, we have a whole new power. You don't have to only multiply by 1. You can multiply by whatever you want, as long as you do it to both sides. That's the power of an equal sign. If you have an equation, you're allowed to multiply by whatever you want, as long as you do it to both sides. And so that's exactly what we're going to do. We're going to multiply both sides. By what? I'm going to take both sides and I'm going to multiply them. Our goal in this multiplication is not to make a common denominator. I don't want a common denominator because I don't want a denominator at all. So what we're going to do is multiply both sides to cancel out the denominator. I'll write that down as my first step. Multiply both sides that's important, it's got to be both, to cancel out the denominators. Well, on the first side, on the left-hand side, what would I have to multiply by in order to cancel out that denominator? Well, if I multiply by x squared minus 1, of course I have to do it on both sides, that will cancel out the x squared minus 1. What I'm going to have to do is distribute this to both terms. And when I do that distributing to the second term, the x squared minus 1 will cancel out. Fantastic. On the right-hand side, when I multiply that fraction by x squared minus 1, it's worth remembering that x squared minus 1 is actually also, because we can factor it, is also x squared x plus 1 times x minus 1. So I'm still multiplying both sides by the same thing. And now when I write it this way, I can see that the x plus 1s will cancel. So to sum up what I've said so far, because this is an equation, we're allowed to multiply by whatever we want as long as we do it to both sides. And what I want to multiply is whatever will cancel out all the denominators. So I'm multiplying both sides by x squared minus 1, which will cancel out all the denominators. On the right-hand side, notice that the x plus 1s will cancel, and then I'll have x minus 1 times x squared plus x plus 2, which, I'm not going to lie, it does look kind of annoying. It's not really going to be that bad, though. You'll see why in a minute. So x squared minus 1 times x, and x squared minus 1, when I distribute it to the second term of that expression, times this fraction here, the x squareds minus 1 cancel. So all I'm left with is plus x squared minus 5. I'm sorry, I wrote that wrong. Hopefully you caught my mistake when I did it. I said x squared minus 1. That's really x cubed minus 1 because we were multiplying x squared times x. Okay, and then on the right-hand side, I have to multiply x squared plus x plus 2 times x minus 1, which I'm going to distribute the x to all three terms. and then the -1 to all three terms. I'm going to erase all this, and you shouldn't leave all that in your notes. I'm just showing you what I'm about to do. If it helps, I mean, if you're comfortable doing it, just writing it as a line, x times x squared, x times x, x times 2. -1 times x squared, -1 times x, -1 times 2. And then combining like terms, that's great. If you can do it that way, fine. If you get a little bit lost when you've got long expressions like that, one option you can use is the sort of the table, x squared plus x plus 2 times x minus 1. So if it helps, you can do your math this way. And that's just another way to see the terms. It's totally optional to do it that way. You don't have to. Some people like it better. Okay, but we have some terms to combine and others cancel out. So the x cubes on both sides will cancel out. The x squareds, this one will cancel out with that one. The negative x's will cancel out. And so when I'm done with all of this, all that canceling out, I will have -5 equals 2x minus x squared minus 2. And hopefully you recognize that immediately that that's a quadratic. And we know what to do to solve quadratics. So I will bring everything over to the left-hand side, so that way my x squared is positive. X squared minus 2x minus 3. And this one does factor. So my two solutions, and I'm doing this quickly because we've done it so many times, but please feel free to pause the video and write this a little bit slower on your own. You should be able to do all of that part that I just wrote down without looking at what I've written down. That's something you need to know how to do. But if not, you can certainly look at what I've done to figure it out. And we have two solutions, right? Oh, I'm sorry. I forgot to write the second step of your directions up here. After we've multiplied both sides to cancel out the denominators, and we had this, well, the next thing that we did was, well, we solved. Because from then on, we know what to do. So that's your next step. And we have two solutions, right? No. Be careful. There are domain restrictions on rational functions, which means you could get answers that don't work. Luckily, you don't have to check the way we've checked other equations before. You don't have to take your two solutions and plug them into the original equation and see if they work. You can if you want to. It's a good method, but it's not necessary. All that's necessary is to check the domain restrictions, which I probably should have checked earlier. I see the x plus 1 and the x squared minus 1 in the denominator to begin with. What I should have done all along was say, oh, that means that x cannot equal 1 or -1, which means if I get that as one of my answers, I'll just ignore it. And so the only solution is that x equals 3. So we ignore the solution that is not in the domain at all.